Why, hello there. Homework 405. Ready to rock this one? This one is out of this world. Get it? Because space. So, reading through this, the second word in this, I have no idea what it means. Word 2. I'm like, yikes, what does that even mean? If only there was a magical thing called the internet that I could type into and figure out what Geos Inachronous Gioscornocorus. Maybe it's Greek. Let's ask Beltakis. Just kidding. I don't have a clip of him ready to go. Or do I? No. Still no. Or do I? No. Or do I? No. Or do I? Geosynchronous. Geo, planet. Synchronous, synchronized. What geosynchronous means is that the satellite stays directly above a singular spot on the planet. Easiest way to think about this is if there was a satellite in geosynchronous orbit with Pelham, if you looked up in the sky, you would see it. And then if you stood in one spot, you would just see it stay directly above you for eternity because it would stay there. Most other orbits, the thing just moves on its own. So it's very, very important, and it gives all the other information. Like most problems, I'm going to start with a drawing. So I have here my terribly drawn planet, right? And then up here I have the probe. Okay. Now, because of everything that's going on here, there is a lot of information. I'm going to make sure to label everything appropriately. But one of the things in question that it's asking for in the end is this. The altitude is defined as the distance from the surface up to the object in question, which is that. However, in my diagram, if I go from here all the way to the center, right, this would be like the radius of the path, right, which would be like that full amount. And then if I go and do this, this would be the radius of the planet Jupiter itself, right? Now you can see that these two would combine together to be the radius of the path, but they're certainly not all the same. Now, if I try to set this up, let's start this off like we would any problem. Making an FBD for this, you certainly can, but it's just FG that's acting. So I'm going to have that F net acting on the probe is going to be FG. Right, and I hope at this point we understand that it's going in a circle. So FNet is mac and cheese. And again, with mac, this is always the probe or the thing going in a circle, which is the probe in this example. So I have that. And from here, I'm going to set these two equal to each other, right, like we frequently do. So I'm going to have FG is mass of the probe, AC, right? And then this would be V squared over R, right? But if we think about what R this actually is, I'm going to put RP here, meaning path, right? Or you can think of where the probe is, would also be okay to think about that as well. All right, so then this would be big G, mass of the probe, mass of Jupiter, divided by R squared, and this would have to be P, right? Because it's from center to center, which is where that is. And this would be equal to MPV squared divided by RP. Whoa, 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 kids, check this out. A boom, a boom, a boom, a boom. Amazing. So let's catch up with where we are. So I got big G, mass of Jupiter, radius of the probe, and that's equal to V squared. Okay, I want altitude. Now, because I want altitude, it's a piece of the radius of the path or of the probe, right? So if I can get the radius of the probe, like a numerical value for it, I know the radius of the planet, and I can just subtract those two and find the actual altitude itself. So I should be able to do that. Now, in a normal problem, right? A normal, regular problem. That might be something closer to what you might see on an assessment. Because again, some of these homework problems are bigger than assessment questions, right? They always have been, and they always will be. I would solve for RP and then do a little magic dance. Because in the end, right, I'm gonna say that the radius of the path or of the probe is the radius of the planet plus the altitude. Right? So if I want just altitude on its own, it'd be the radius of the probe minus the radius of the planet Jupiter would give me the altitude. Don't have this, do have this. So I still need to find that in order to do this. That's my end all be all. Yikes. Here's a little trick around here. I don't know what V is. And looking at the problem, it gives me time, which is fine, but I don't know literally anything else. So here's where I have to sort of pause and try to brainstorm. Now, if you think back to homework 403, we did a little trickerinsky. If we think about speed for things that are constant speed, it's really about how far it goes and how long it takes. How far it goes and how long it takes. That's really what speed is for constant values, that are things that are unchanged, right? Now, in this example, we know how long it takes for the rotation, but let's imagine there's a satellite that is geosynchronous above my nose. If I spin around and I get back here, it's gotta, that was a weird sound. It's gotta be in front of my nose still. Yeah, so let's just, so if this takes, I don't know, 9.84 hours, that means the time for my nose to go all the way around was 9.84 hours. And the time for a little probe minion is 9.84 hours. So, do I know the time it takes for this probe to go all the way around? Absolutely. Do I know the distance it travels? No. If only there was some royal way to find out the distance something travels when it's like a circle and stuff. If only there was some knightly way, royal way, knightly, royal, circumference is 2 pi r, right? So if we're thinking about for this thing, well, the distance to travel is actually like 2 pi rp. That's how far it goes. So if I think about the speed, well, it's really just 2 pi rp divided by the time it takes. And can we just leave it as delta t? Are you guys okay with just leaving it as delta t for now? Is there any way to not? I know that. I know it's 9.84 hours, right? And that 9.84 hours or 35424 seconds, because I typed it into Google. Either way. This is now the key. But you might say, Mr. Lee, I don't have a number for that. If only we do everything algebraically and solve everything algebraically, so I don't care that I don't have a number for it right now. If only. If only. Here's my move. I'm going to take this, I'm going to put that there, and I'm going to try to clean this up solving for RP. You might already see an issue I'm going to have, so I'm going to have RP on both sides of the equation. But let's pause for a moment. We're about to do some algebra, hardcore algebra. We need to make sure our algebra skills are good, firm, and ready to rock, ready to roll, ready to move, ready to groove. Important things right now. At this point, we should understand that circle stuff means mac and cheese. And what am I doing with mac and cheese? I'm figuring out why it's being all mac and cheesy. And this reason is FG. If I don't know the speed for circular stuff, I'm probably going to bring circumference in. That is like pretty common at this point when we're doing it on a fairly regular basis. Good? This coffee is cold at this point. It's weird. Warm coffee? Sweet. Iced coffee? Amazing. Middle of the road coffee? Most people are like, ew, gross. Me? That's fine. I don't choose it. But like, what am I supposed to do? Heat it up with my Twilight Woods candle. Twilight Woods and amber Threshold. Sponsored. Smells like Twilight. Not the film series or the book series. Like the time of day. Twilight Woods. Let's do some algebra. So when I sub this in, I'm going to have big G, the mass of Jupiter, divided by RP. And then on the other side, I'm going to have 2 pi RP all over delta T. But remember, all of this is in fact squared. And this is where it might get a little confusing. So let's just try to roll together and do our best. So big G MJ over RP. Now I have to square all the stuff. 2 squared is 4. Pi squared is pi squared. RP squared is RP squared. Divided by, this would be delta T squared. Ow! Yikes. Oh, yeah. Wow. I'm going to drop this a little bit. Looks like it's going on. All right, that's probably a little better, maybe. All right. RP and RP. You might be saying, hey, let's cancel that out, boy. No, you actually can't cancel. If I were to multiply both sides by RP, multiply by RP, pow, pow. On this side, you can see that I have RP squared times RP. So this is actually big G MJ is equal to 4 pi squared, right, times RP cubed over delta T squared. Yikes. Little algebras here. I'm trying to get RP alone, right? So I will multiply both sides by delta T squared, right? Multiply by delta T squared. So that way that'll cancel. And then the other algebraic move here is I'm going to divide both sides by 4 pi squared. Divide by 4 pi squared. So that way the 4 will cancel with the 4, pi squared cancels with the pi squared. And I'm left with here is, it looks like I have delta T squared. I got big G, I got MJ divided by 4 pi squared. And this is all equal to RP to the third. To the third? What are we, to the thirds? Now, if I wanted to, I can rearrange this the numerator if I wanted to put it in a different order, maybe. But the only way to get rid of RP, to get RP all alone by itself, is that nasty, nasty cube root. And that's not weird sounding. What's blowing up here? I'm back. It's just a noise. So I cube root both sides, right? And let me just move this over here so I can leave this on the screen for you to see. So I mean, I'm partial to rearrange the numerator a little bit, just because I feel like big G should always be out front, but doesn't matter. And this is delta T squared, right, divided by 4 pi squared, and all of this is under a cube root, and this is equal to RP. So from here, I'd have to plug in numbers. Now, the big concern of mine, obviously, always is button pressing. Remember that we know these values. So big G, 6.67 times 10 to the negative 11 Newton meter squared per kilogram squared. No big deal. MJ is given in the problem as 1.898 10 to the 24 kilograms. The time, we can't be in hours, going to be in seconds. So 3, 5, 4, 2, 4 seconds. Plug that in. Pi squared, 4 is 4. Bing, bam, boom. And I'm going to get that RP then, after I plug in all those numbers, is 1.58 times 10 to the 8th meters. And we're done! We did it!
Not so fast, Mr. Winley. You're not done. You're not done. You're not done yet.
That's RP. And remember, we had said earlier that in doing this problem, that RP would be the radius of Jupiter plus the altitude. And the altitude is actually what it was after. So I need to actually take RP, subtract the radius of the Jupiter, and that will actually give me my altitude. And then after doing that, I end up with 8.756 times 10 to the 7 meters. That's my final answer. Yikes. So all of this is just some algebra, realistically. That's not actually any math questions there. All of not any physics there really. It's all just algebra. If we scroll back up, we'll talk about the foundational big parts of this problem that are important for me going forward to future problems. At this point, looking at these questions, this is got to be what we're doing. It's going in a circle, mac and cheese. Why is it going in a circle is what my FNet is. And then I can, set those things equal and attempt to solve. And when I get stuck, that's the trick, right? Basically, if you start solving and you get stuck, that's the trick. And we don't freak out when we get stuck. We say, what else can I do? The trick here is a trick that we're going to see a couple times now, is that we're using actually circumference, and it's basically the circumference divided by the time is how fast objects are going to move when we're dealing with circular motion. And then from there, we're just doing a little grindy grind on the algebraic solutions there. So I hope that helps you out a little bit on this. It's the algebra. It's beefy algebra. Cube root for sure is not something that's seen very common, but still important for us to flex those algebra muscles. You only get better. No pain, no gain, I've heard from the gym. People say that. But, also algebra muscles, stretching those. I hope this helps. Good luck, and until next time.